Hello. Hey, this is test corrections for the Unit 4 Test A. And remember, you're going to correct it on your test, the problem, and then you'll rewrite these answers on the test corrections paper, and that will get you a 3. And then if you want a 4 for mastery, then you'll have to retake this test, or the particular learning target anyway. Okay, let's take a look at learning target 1 and 2. I can identify an ordered pair as a solution to a system of two linear equations from an equation or a graph. So on number 1, it says, is 214, that coordinate pair, a solution to the system? The system being those two equations. And you're going to have to show your work or explain how you know it is a or is not a solution. So what I'm going to do is just plug it in. So here's my x, here's my y, and I'm going to see if that makes these two equations true. So y is 14, so I'm going to fill that in for y, equals 2 times 2, that was my x, plus 10. So when I plug that in, it says 14 is 14. So it makes that equation true, and they are equal to the same thing. And then on this one, if I plug in 14 for the y equals negative 2 times 2 plus 18, I'm starting to see that it's still going to be true, equals negative 4 plus 18. So negative 4 plus 18 does give me a true statement, 14 equals 14. And the coordinate pair works to make those equations true. So I have just shown algebraically that, yes, that coordinate 214 is a solution to that system. When I look at the second one, negative 2, 3, and I look at the graph, I see that the intersection point here is x is 3 and somewhere around 3, just a little bit less, and y is a negative 3. So my coordinate is something close to 3, negative 3. And I go up and look at this coordinate and I see it's negative 2, positive 3, and that's up here, right? This coordinate is there. It doesn't even fall on either line. So it can't be a solution to the system. So that is not, nope, a solution. And I've just shown you that the point doesn't fall on the line through my picture. Okay, so that's 1 and 2 for learning target 1 and 2. And then learning target 3, we're looking at the different situations on systems and identifying what's going on. So we have to identify if there's one solution, many solutions, or no solutions. So on 3, I can see that there's kind of 2 arrows here, and that indicates to me that that is 2 lines and they are in the same place together. So no matter what I do, I take an x coordinate 3 and or like a kind of here a 2, 1 coordinate, they are going to, that 2, 1 is going to be in the same place on both lines. Or come down here, this negative 1, negative 3, it's going to be good for both lines. It will fall on both lines. So because it's 2 lines in the same place, it doesn't matter what I pick for x and y, it's going to be on both lines. So that is infinitely many choices. Infinitely many choices. When I have parallel lines in this system, they are never ever going to cross. So they are just going to continue apart, never cross. So I can't ever have a solution for that system. And here, you could imagine that this line keeps going. And so you could have said 1, but the printing was kind of goofy on this. So you might have thought there was supposed to be 2 lines here. So it could have been many as well. Kind of depends on how you interpreted it, and I will probably not count that one. But if you just wanted to know what we were aiming for there. if it was the double line many that you were seeing, or if it was a line that could continue, you could imagine it would intersect and you would have 1. And then finally, learning target 4, you are trying to solve an equation by graphing it. So in this system, we're going to graph them, and let's take a look at, straighten it out a little bit. The first one, so to graph the first one, remember, this is your intercept. So that's the y-intercept. That's where we begin. We call that the B for the begin. So when I'm graphing it, I'm going to go down to -3, and then I'm going to use my slope to create some points. So I'm going to go up 2 over 3, down 2 over 3, and I have my first line. I'm going to try to draw it as straight as I can. So if it continues on somewhere to intersect, I'm getting all those points. My other line has a y-intercept of 2 and slope, and this is a negative here. So I'm going to have to, one component of it's going to have to be negative. So down 1 over 6. Oh, I didn't have to go very far on that one. So when I graph that, I'm going to see that I'm crossing the line right there. And that point is 6 is x and 1 is y. So the solution to that system is 6, 1. Then on these two, I could do the y-intercept, x-intercept method, but here I see, like, if I made y0, 6 times 0, 4 times something is 6, would kind of turn it into a decimal, and so I'd have to go in between the lines, and I might not be so accurate. So I think I'm going to reset these equations up into y equals mx plus b form. So to do that, I'm going to have to subtract 6 or x from both sides here. And I'm going to have 3y, that turns into 0, so I can 0 it out. I'm going to have 3y equals negative x plus 6. And I have to have it in y equals mx plus b form, so I'm going to have to divide every single term by 3. So my new equation is y equals, and remember that's a negative 1/3 x plus, I'm going to reduce that to 2. And that helps me with my slope when I say negative 1 over 3. So my intercept is 2. My line is going down 1 over 3, or up 1 positive over 3 negative. And so trying to draw as straight a line as I can, if you have a ruler, even better. Okay, and the other one, I'm going to just rewrite it over here so I have a little bit more space. And I'm going to subtract my 4x to move it away from the y. So that's going to 0 out. I'm going to have negative 6y equals 2 x's. And, oh, what am I doing? I can't, sorry. I'm going to have 6 minus 4x. I can't do that. They're not like terms. All right, then I'm going to divide each term by negative 6. So negative 6 divided by negative 6 is 1. Y equals negative 6. 6 divided by negative 6 is a negative 1. And negative 4 divided by negative 6. And if I reduce that, it's going to be a positive 2 over 3x. And then this is going to be minus 6 divided by negative 6 minus 1. So y equals 2 over 3x minus 1. So when I start this, I'm going to be at -1. I'm going to go up 2 over 3. And that wasn't too bad. I'm going to intersect those right there. So my intersection point is 3 for x and 1 for y. And that's my solution to that system. So that's it. Those are the 3 learning targets. 4 really, right? Learning target 1 and 2 are together, 3 and 4. So now rewrite your corrections on a test correction paper. Show the problem on the left, explain how to do it on the right, and turn those in for your 3. And remember, if you want a 4, you'll just retake the test. All right, thank you so much. Good job.